Hello, pre-algebra students. We're ready for 13.8, where we are talking about counting outcomes. You should be familiar with the idea of a tree diagram. A tree diagram is a visual display used to find the number of outcomes given a number of choices. The number of outcomes given a number of choices. Another method that relates to the number of outcomes to the number of choices is the fundamental counting principle. So this is a very important concept. So I am not going to make you do a lot of tree diagrams because they're very time consuming, but you need to know the fundamental counting principle. If event M can occur in M ways and it is followed by event N that can occur in N ways, then the event M followed by N can occur, and here it is, M times N ways. Now that makes no sense because it says M and N and M and N. So let's look at it with something tangible. Example 1. How many different combinations of beverage, bread can be made if there are 3 beverage choices? So here we go. 3 beverage and 3 bread. So here's our tree diagram. They decided to make coffee, tea, and juice the 3 beverage choices. And then there were 3 bread choices. So for coffee, you could pair coffee with a bagel, with a muffin, or with a scone. And here's where they wrote the outcomes. Okay. Then tea, you could have tea with a bagel, or tea with a muffin, or tea with a scone. And then there's also juice, and you could have juice and a bagel, juice and a muffin, juice and a scone. So there are 9 possible outcomes, and there it is summed up in this box. So if you don't want to take the time to make a tree diagram, if you look down at the bottom, here we have using the fundamental counting principle. Instead of a tree diagram, we have 3 beverages and 3 bread choices, and 3 times 3 is 9. And I don't know about you, but I think that's a whole lot quicker than drawing the tree diagram. It's good to know that you can draw a tree diagram. Alright, so let's look at number 1. A closet has a red top, a blue top, and a white top, and pants and a skirt. Okay, so here we have our tree diagram started. So the red top, I can either wear a red top with pants, or I could wear the red top with a skirt. I could wear the blue top with pants, and I could wear the blue top with a skirt, and I can wear the white top with pants, or I can wear the white top with skirts. And so we see that there are 1, 2, 3, 4, 5, 6 outcomes. Now let's look at the fundamental counting principle and see if we would end up with the same thing. 3 different tops, 2 different bottoms. 3 times 2 is 6. We would get the same number of outcomes. Okay? I would like for you to try to draw the 3 pennies. Of course, it's heads or tails, and see if you can come up with how many outcomes. Do a tree diagram first, and then check yourself with your fundamental counting principle. Alright, so 3 and 4, we're using the counting principle. 1 6-sided number cube, so that means we have 6 outcomes on a 6-sided cube that is rolled, and 1 card is drawn from a 52 card deck. So 6 possible numbers to land on times 52 possible numbers in a deck of cards. And so 6 times 52, 12, that's 30, 312 possible outcomes. Ordinarily, I'd ask you to do number 4 on your own, but I want to be sure if you know that we're talking about digits from 0 to 9, then that's 10 possible digits because you're counting 0. Okay, and then one letter. How many letters are there in the alphabet? 26 letters in the alphabet. So 6 letters. There's 26 possible letters you could choose and 10 possible digits, so 260 possible outcomes. Alright, on the continued 13.8 notes, we're still counting outcomes, but we're going to find the probability of an event. When you know the number of outcomes, you can find the probability. Remember, probability is winners or desired outcome divided by total possible. So our first example says we have an ice cream parlor has a special where you can build your own sundae for $3. Excuse me, that's my dog wanting a drink of water. Hold on. Okay, where was I? So at the parlor, you're given a choice on this day that they're having a special of chocolate, vanilla, or strawberry ice cream. So that's 3 different kinds of ice cream. All right. And then you can have sprinkles or nuts. So that's 2 different toppings. And then you can have chocolate or caramel topping. So that's 2 different kinds of, they call it wet toppings. These were your sprinkles or nuts. These are your caramel or chocolate. Okay? The counting principle tells us 3 times 2 times 2. 6 times 2 is 12. We have 12 possible outcomes. All right, that's what we just talked about on the first page. So then it says, what is the probability? Let's read this last part. What is the probability of randomly selecting vanilla ice cream with nuts and either chocolate or caramel topping? Okay, so now my total possible, so probability, let's review. Probability is the number of winners divided by total possible. And so our total possible here is 12. Now what's going to make this a winner? I need vanilla ice cream, so that's 1. And nuts, that's just 1. And then either chocolate or caramel, so that's 2 possible winners there. Either one of those is a winner. So 2 over 12, so the probability is 1/6, which is approximately, how much percent? Let's see. So that's a 16% chance. All right, the exercises at the bottom. Since the clothing question is similar to the one I did on the first page, let's look at the cell phone question. There are 6 cell phones and 23 covers. If each cell phone is made by a different company and each cover is different, what is the probability of randomly picking a telecom phone with a green cover? All right, so there's 1 winner, telecom, and 1 color winner or 1 cover winner, which is green. So our winners are 1, because 1 times 1 is 1. Then our total possible, since there's 6 different cell phones and 23 covers, our total possible is 138. So the probability is 1 in 138, which is approximately 0.7%. All right, I'm going to let you do number 3, and let's tackle number 4. All right, a nickel and a dime are flipped. What is the probability of getting tails, then heads? Okay, so I have 2 coins. Well, for the nickel, the probability of tails is 1 out of 2 because I have heads or tails. And for the dime, the probability of getting tails is 1 out of 2. So that equals 1 out of 4. So that's our first time. So what is the probability of getting tails, then heads? So we have the exact same probability of getting heads. So we had tails first, and then 1/4 is also the probability of getting heads. So to get this and then that together is 1 out of 16. 4 times 4 is 16. All right. Go ahead and try 5 and 6 as well as 1 and 3, and we will talk about those tomorrow. Have a super day.